August 12th, 2016. Guys, you're looking at a graphic of the solar system starting with Saturn in the right corner. It appears larger than Jupiter there in the bottom, but that's only because of the proximity of the artist as he's looking toward the inner solar system. Notice some of the moons there to the right of Jupiter, and that has everything to do with part 3 of this series, and it's not the last part. But what you see from Jupiter inward is the asteroid belt. Then you see Mars, the Earth, Mercury, Venus, and you see the moon around our planet, again, Earth there, and the sun in the center. Now, you've got the moons rotating around Jupiter, and you're going to have to crunch the numbers. That's going to be in part 4, but I'm going to give you some good ideas here. Now, in this graph, you can see it's exaggerated as far as the size of the planets. But again, Jupiter with its planets, asteroid belt, Mars, Earth and the moon, Venus and Mercury and the sun. Now, what would it take for Jupiter to move closer to the Earth? And it actually does by about 300 million miles at its closest point in its rotation. But check out this graphic. To the left, the orange line is the size of the sun. These are actual scale. Then Mercury, Venus, Earth and the moon, Mars, asteroids. Then the 4 moons of Jupiter where it says Jupiter, but the large brown circle, guys, is Jupiter. Then Saturn, Uranus, Neptune, and then the moons of each one. And notice how even Uranus and Neptune are so much larger than the Earth. Here's scale of Jupiter and the Earth. We'll take 1,300 of our planets to fit inside of it, but it's just on the other side of the asteroid belt from Mars, and it's the largest object in the solar system other than the sun. Now notice your timestamp, which is yesterday as I was starting to put some of this together, October the 11th, and this is the actual location of the planets at that time. The Earth, Ceres, Mars is on one side of the planet. Now Ceres represents one of the largest objects in the asteroid belt, and it represents the orbital path of the asteroid belt, except you're dealing with millions of objects. That's almost 1,000,000 miles, 99 million miles wide, 1 AU. Now here's a couple of dates. October 26, 2017, Jupiter will be at the solar conjunction. 214, May 9th, Jupiter opposition, Jupiter solar conjunction. Those are the dates that give you as far as the important dates, but I want to look at some of the other dates here. Again, October 11th, yesterday, timestamp. And on this solar system scope model, you can just grab any planet, start rotating it. Notice your time stamp at the bottom. Earth and Venus is just lined up. Venus and Mercury are lined up right here. As I back this up, let's come back forward. Notice Jupiter, the Earth, Venus, and Mercury are within the magnetic field of the width of Jupiter, because it has a magnetic field 18,000 times larger than the Earth's magnetic field. Now check this out. April 10th next year. So you've got April is the 4th month. We're into the 10th month, so we're about 6 months exactly. And we've got an alignment between Jupiter, the Earth, Venus, and Mercury. To me, this is much more important than the conjunction date. And everything has to do with the magnetic fields, guys. And this is going to get deeper as we go into the couple more parts. They're almost ready, just finishing touches. But Jupiter's magnetic field goes out about 4.3 million miles. That's in front of Jupiter. As we come around, notice Mars is going to line up on February, March 2nd, 2018. Now, Mars is closer as far as any effect as far as the asteroid field, because the asteroid field lies between Jupiter and Mars. But about 4.3 million miles out in front of Jupiter is the outer extent of its magnetic field. But guys, the blowback, just like the Earth has a magnetic field, and then it has the bow shock, and then you have the magneto tail that extends for millions of miles behind it on the opposite side of the sun as it faces the solar stream. Well, Jupiter's solar stream goes back to the orbit of Saturn about 4.3 AU. Now that's 4.3 times the distance of the Earth to the Sun. That's further than the closest approach of Jupiter and the Earth. Jupiter and the Earth at its closest approach is about 3.8 AU. The final touches on this, if you haven't already started to see what's going on, will be in the details of part 4. But here we're dealing with Juno. We're dealing with 4 months ago. And Juno is the satellite that we've sent up to study not only Saturn and its moons, but what is a very key part of the end of this, which is a moon of Titan and Saturn. But Jupiter is known as Nibiru in the ancient text. I showed you that before. But guys, pay attention to this, what they're talking about with Jupiter. It says, one of the brightest objects in the night sky, Jupiter has enthralled humans since ancient times. Today, scientists believe that learning more about the planet may be the key to discovering our solar system's origins and formations. They theorize, and they know, that Jupiter didn't always rest where it is now, but that it moved throughout the solar system in its youth, disrupting the formation of Mars, influencing the formation and location of the asteroid belt, and more. Just like I've been telling you. Notice the date, August 5th, 2016. Juno came through there getting these pictures on July 4th. There's in the next part of this series, we've got recorded the Juno satellite as it hit the front bow shock. But guys, the whole thing about this is the magnetosphere of the Earth, the magnetosphere of Jupiter. And did you know that Ganymede, the largest planet, is the only moon, supposed moon in the solar system that has its own magnetic field? And it's larger than Venus. Think about that. That magnetic field can be disrupted. Ganymede could crash into the magnetosphere, into the asteroid belt, just like it possibly has done before. What would it take? A magnetopause reversal. In the next part of this, guys, I'm going to show you 2 magnetopause reversals that could have affected the entire inner solar system, and you've seen them on my channel. And I'm going to tie that into how Ganymede could be released, as well as some of the other moons, because 4 of the Galilean moons are planetoid objects that are very large. Guys, why are they spending billions watching this? You saw where NASA said that they think Jupiter has done this before, disrupted the inner solar system, just like the ancients said that Nibiru did. And you've seen where you can trace it back through the Phoenician languages, through the Sumerians, that they called Jupiter Nibiru. Guys, it's so huge. 130 of our planets could fit into it. And this is just an animation of its moon Ganymede that's larger than Venus. This is what they were picking up as far as its magnetopause and the auroras around it. Look at that. It has a magnetofield and it has auroras, and so does Jupiter. These are massive. That tells you they have magnetic fields. Just a reminder that you've seen this in part 2, that the Sumerians had called Jupiter Nibiru, and also Mulababa. You can pause this. Bright sun like star. Nibiru simply means ferry, ferryman, or ford. Micas Nibiru is the toll one has to pay for crossing the river, and is another title for Jupiter as it changes position and crosses the sky. Guys, study the orbit of Jupiter. It can appear to go backwards. That's because it has an 11.8 year orbit around the sun for every year that we do. The Earth goes around once a year. It goes around 11.8 years. It appears to go backwards at one point. It has a lot to do with that crossing. But guys, in the next video, I will have the time to show you how a magnetic reversal, which has happened twice in the last 4 years, and if it happens as we have a closer approach to Jupiter, then that would be all it would take. But the date would be hard or impossible to set because there's too many factors. But it goes back to the Bible scripture that we talked about in Job. Said, and he was telling Job, you don't know the hell that I have in my storehouses for that great day of the Lord, the great day of battle. And we won't know that date because it could happen at any time. It entered the solar system before it could throw out one of those large planetoid moons into the millions of asteroids that are in the asteroid belt. That at one time was a planet that they call Tiamat, that we see the remains of it, and the moon could possibly was captured in the orbit of our planet because of that chaos. Because Jupiter has been right before our eyes. They're not going to talk about it that much. They're watching it very closely. Stay tuned for part 4. It's a heads up. Be safe.